RailCorp's new Boundary Street Bridge in Roseville on Sydney's North Shore. The 3,500-ton superstructure is built for growth, space for 4 tracks on top and 6 lanes beneath, together with increased height clearance and a design that reduces rail noise. Built in the 1920s, Boundary Street Bridge had become one of the worst pinch points on Sydney's road network. Here, a major 6-lane road was forced into just 3 lanes, and with a clearance of only 4.2 metres, the bridge was frequently struck by overheight vehicles. RailCorp began planning the new bridge in January 2009. The challenge? Lift and widen the bridge while minimising disruption to motorists and train customers. And all without disturbing the 2 Epping to Chatswood rail link tunnels just 10 metres beneath the bridge site. The solution? 2 33-metre transfer beams anchored to specially constructed free-end bearing pilings to straddle the tunnels and support the weight of the bridge above. With such long transfer beams, it also meant the main section of the new bridge could be assembled next to the old one and then slid into place. Work began in January 2011 with the relocation of overhead electrical cables to a new temporary services beam next to the bridge. In March, the project's first major track possession began. The tracks were removed and excavation began on the southern side of the bridge. More than 2,000 tonnes of material were removed. To allow construction to continue without halting train services, crews were to install 2 15-metre steel working tubes, 3.7 metres in diameter beneath the railway. With the first tube precisely in place, a rock slinger was used to rebuild the abutment. The fill was cement stabilised to increase its strength. Work continued with less than 20 hours until the next train was due. And despite the continuing rain, the track was reinstated in plenty of time for handover. With the first working tube in place, work could begin on forming of the transfer beams without any interruption to the busy train line above. The next phase was to create the free-end bearing pilings. In order to do this, the pile size would need to be overboard to accommodate a specially constructed 15-metre steel casing, which was then inserted into the shaft. The additional cavity outside the sleeve was filled with pea gravel, which lets the pile move without transferring any of the lateral load. A smaller diameter bore head was then used to drill a further 3 metres into the bedrock. Once it reached the precise level, the preformed Rio tube was lowered into place and concreted in. All 4 piles were completed in less than a month. Meanwhile, preparations were underway to install the second working tube. This occurred in April with another weekend possession. Completing the transfer beams was a major challenge. With the density of the reinforcement required, the distance the concrete needed to travel, and the limited access within the pipe, ordinary concreting methods would not be appropriate. So the team turned to a specially formulated self-compacting, self-levelling concrete. Working closely with roads and maritime services, Boral and industry experts, the team developed a lighter viscosity concrete formula that didn't require compacting.
Rather than adding any more cement, because we don't really need to do it from the point of view of the strength, because the designers confirmed that you only need 40 megapascals, I was thinking of cutting back the fly ash content slightly. It's just basically not altering the aggregates that much, but just altering the blend. The idea is we'll cut the beam in 4 places and look at the cross-section to see whether or not it's fully encapsulated all the actual intrusions and the reinforcing bars. If there's any big issues, they should show on the form face and also on the cut.
With the formwork now ready on the south end, the first pours began. Meanwhile, the crew was busy building the formwork for the main abutments and cantilevers, which were to be built on site. Once the beams were set, special stainless steel plates were installed, which would be used for sliding the bridge. These were then sealed up, ready for the slide in December. The abutment pieces and cantilevered sections of the main bridge were trucked up from the yard and set in place. The assembly of the main bridge section happened on the 25th of September. It was the second complete road closure for the project. However, trains were not interrupted. 2 90-ton girders, 11 cross slabs, the approach slabs and other precast components were assembled in the yard ready for installation. Traffic was stopped on the Pacific Highway while the first girder was brought up. With such a tight working area, a dual lift was required, using a 400 and 250-ton cranes. The bridge came together without any problems, and by morning it was fully assembled, ready for concreting. The eastern abutments were formed and cast in situ, while the western abutments were formed and cast nearby. Starting at midnight on Boxing Day, the crew had just 5 days to complete the final major works for the bridge. It was essential that the week-long road and rail closure ended in time to let New Year's Eve revellers get to the city. The first step was to remove the old bridge. Sand was laid to protect the roadway, scaffolding was erected for work platforms, and the lancing and cutting began. Within hours, the old bridge had been taken away. The excavators moved in to remove some 2,000 tonnes of material, including the old brick abutments and the stabilised sand that covered the working tubes. The tops of the work tubes were cut and hauled out, revealing the transfer beams. The stainless steel sliding plates were uncovered and cleaned up in preparation for the bridge slide. A test slide had been performed 2 weeks before, and the hydraulics and rigging were ready to go. The crew used special high-tech lubricants to turn the plates into near frictionless surfaces. At dawn on day 2, the bridge slide began. It took only 50 minutes to slide the 1,200-ton structure into place. After the final adjustment, the bridge was in place to within a few millimetres of the design. With the main bridge and eastern girder now in place, the next step was to install the eastern decking and the approach slabs for the main line. Meanwhile, the final removal of all the materials under the bridge was completed. The 400-ton crane was then relocated to the western side of the bridge for the final stage, assembling the western deck. The 2 abutments were lowered into place and braced. Then the western girder and cross slabs. And after just 3 days, the new bridge was virtually assembled. There were 2 days left to finalise the smaller details and restore the track. The new bridge was 40 centimetres higher than the old one, so the approaches also needed to be raised. The handover went as planned, and the road and railway were reopened with plenty of time for New Year's Eve revellers to get to the fireworks. Final works were completed over the next couple of months, with the project finished on time in March 2012. City Rail customers, motorists and the local community can now enjoy a bridge that's stronger, quieter and ready for growing road and rail traffic.